Let us learn the existence of limits in this video. In our previous video, we've learned how to evaluate some limits. Now, what is really the condition for a limit to exist? Now, we already know that if I have the limit as x tends to a of f of x, this means that I'm having the limit of a function f of x as x approaches a. Now, this is the new thing you have to learn. Let me assume that, look at this. And I have this A that we have here. Look at this A. Let me say I have A here. Take note that this X can approach this A in two ways. How many ways? Two ways. It can approach A from the left. X can approach A from the what? From the left. Also, X can approach A from the left. Also, S can approach A from the right. Good. S can approach A from the left and also from the right. Now, if x approaches a from the left, we will rewrite this limit as the limit as x tends to a negative of f of x. And if x approaches a from the right, we will write this as limit as x tends to a positive, then f of x. Caution, this a negative does not mean minus a. No. This and this do not mean the same thing. Take note of that. This minus and this plus is just telling you the direction in which x is approaching a. Now, what is the condition for a limit to exist? What is the condition for a limit to exist? Now, this is just one condition you need to take note of. And this is the condition for a limit to exist. And the condition is this. If this limit is true, then the limit as x approaches a from the left must be equal to the limit of that function as x approaches a from the right, as required. Once you are able to establish that this and this are equal, then the limit exists. You'll be confused. How do we evaluate this? It's very easy. Observe the graph once more. If I have the graph, look at it. Remember that if x approaches a from the left, this is it, and from the right, this is it. If you observe, if x approaches a from the left, I'm looking at values that are less than a. That is here, you are looking at values that are like less than a. You can see less than. And if x approaches a from the right, it means that what is approaching it from this direction. It means that what is approaching it from the direction of values of x that are greater than a. Take note of that. If it's approaching from the left, value less than a. Approaching from the right, values greater than a. Now, since we know this, let's go ahead to solve some problem. Some will be easy, while some will be straightforward. So let me erase so we solve the problem from the beginning. All right, this is the first question. If you have a function of f of x that is defined this way as x squared as x is less than or equal to 1, and this function f of x is 4 minus 3x if s is greater than 1. Okay, this is what we have. How do we evaluate? You have to check. You have to check if the limit exists as x equal to 1. Check, does the limit exist at x equal to 1? That is the question. Okay, for a limit to exist, you must check the left hand and the right hand limit. Let's check the left hand limit. The limit as x approaches a from the left of f of x. Now, what will you do? How will you evaluate this? Remember, this means that x approaches a from the left. And the meaning of this means that you are looking at the values that are less than a. And my a here is 1. Okay, let me show us. Look at it. Let me say this is 1. X approaching a from the left means that we are looking at values of what? X that are less than 1. Now, the function of f of x you pick here is the one that have x less than 1. That's it. Now, which of these have x less than 1 is this first function? So, therefore, you are going to be saying limit as x tends to 1 from the left. The f of x you are going to pick here is the one with x less than 1. And that is what? X squared. So, how do we evaluate it? Remember, this 1 minus doesn't mean minus 1. it means just 1 that we are checking. So here I will have 1 square if you input direct substitution and the limit is equals to 1. It has been evaluated that way. Next, let's check the right hand limit. I'm having the limit as x tends to 1 from the right of f of x. Remember, if I'm looking at 1 from the right, I'm looking at values of x that are greater than 1. And which one has greater than 1? This one. So which function are you picking? You are picking this function, x, we have this. So you are picking this function, 4 minus 3x. So direct substitution, I have 4 minus 3 times 1. 4 minus 3, and my answer is equals to 1. So what will we do from here? Observe. You can see the left hand limit of f of x is equal to the right hand limit. Did you observe that? They are both equal to 1. So since the left hand limit and the right hand limit are equal, thus the limit exists as x tends to what? 1. So that's it. As x equals to 1, or exists as x tends to 1. X tends to 1. Good. Alright, that is it. So the limit exists as x tends to 1. Let's look at another question. Now, the next question is this. Assuming you have a function f of x defined like this: x squared plus 3, 3x plus 7. Here, if x is less than 1, and here if x is greater than or equal to 1. These are negative 1. Negative 1, negative 1. Now, the question is, find the limit. You have to find the limit as x tends to 1 of the function f of x. You have to find this limit. Now, pay attention. If your left hand limits give you one answer and the right hand limit give you another answer, if the answers are the same thing, then the limit exists. But if the answers are different, you see here, your final answer will be what? Does not exist. The left hand limit and the right hand limit must be equal. Let's look at this question. So let me look at the limit as x approach 1 from the left of that function. Now, if I should ask you, which f of x value will you pick here? Remember, if x approaches 1 from the left, I'm looking at the values of x that are less than 1. And here is where I have less than 1. So f of x here is what? X squared plus 3. So I have the limit as x tends to 1 minus x squared plus 3. And remember, 1 minus does not mean minus 1. It means just 1. Okay, this is minus 1. This is minus 1. Just minus, yeah. Where you are checking actually here is minus 1. So I'm having minus 1. So you are just considering this minus 1 and not this minus that you have here. Okay, so let's go. So we have minus 1 squared plus 3. This will give me 1 plus 3, and my answer is equals to 4. So I'm looking at the limit as x tends to minus 1 from the right. Now, remember, if x approaches minus 1, well, what we are checking here is minus 1. If x approaches minus 1 from the right, it means that I'm looking at the values of x that are greater than minus 1. Where do you have greater than minus 1? This is it. And you have 3x plus 7 to be the function. X minus 1 from the right, or 3x plus 7. So this will give me what? 3 times negative 1 plus 7 minus 3 plus 7, and that will give me 4. So you can see, so the left hand limit is equal to the what? Right hand limit. And therefore the limit as x tends to minus 1 of f of x is equal to 4. That is correct. So you can see. Now, all these are straightforward. Let's move to stage 2. Now, assuming you have a function that is defined this way, and the function is this. You have, okay, let me say you have x squared plus 2, and here you have 4a plus 2. Here you have x less than 0, and here you have x greater than or equal to 0. This is what you have. And if we have been told that if the limit as x tends to 0 exists, then find the value of a. Find the value of a. Yeah. If the limit exists, find the value of a. Okay. Solution. Let's solve this together. Now, we already know that for the limit to exist, this is the condition. As x tends to 0, we are looking at 0 from the left of f of x must be equal to the limit as x tends to 0 from the right of f of x. Now, remember, the limit as x tends to 0 from the left means that we are looking at value less than 0. Where do you have less than 0? This is it. So the function you are going to be picking there is what? X squared plus 2. And here you are looking at value greater than 0. This is where you have greater than. So you have limit as x tends to 0 plus or for a plus 2. So this is what you have. Okay. So what do we do from here? Here, what's our limit? Substitute 0 here. I'm having 0 squared plus 2 here. Looking at this place, nowhere to substitute 0. So you still have your 4a plus 2. Yeah. There's no place to substitute 0. You still have 4a plus 2. That's it. So here, my answer is 2 equal 4a plus 2. And what do we have here? This will give me, so here I'll be having, okay. Let me see the upload. Okay, so you are having 2 equal 4a plus 2. And 4a equal 2 minus 2 will give me 0. Then my a is equal to 0. Now, that is it. So the limit exists. Okay, so let's cross-check our work again. So this is 0. Substitute 0 here. No place to substitute the 0. All right. So that's that about that. So this is what we are given. So that's it. All right. That's about that. Okay. Now, let's look at this question. This is another level in which you can be tested on the existence of limits. Now, you have to find the limit as x tends to 0 of absolute value of x over x. Now, how will you solve this? Now, the first thing you have to do here is this. You have to, firstly, you were not given a piecewise function here. This piecewise function where you define f of x to be something and something. Here, you were not given a piecewise function. So what do we do here? Okay. Firstly, you should note that this absolute value of x is defined as this. This is the definition. This absolute value of x I'm having here will give me x if x is greater than what? 0. Do you still remember the definition? If x is greater than what? 0. And it will give me what? Negative x if x is less than 0. Let me tell you why. Let me explain it. What is absolute value of 3? And what is absolute value of minus 3? Remember here, x is greater than 0. Since x is greater than 0, it's still going to repeat the same x back for me. And this is what you see. Absolute value of x. If x is greater than 0, what am I going to have? I'll still have my same x. And this is it. And my x is what? 3. Let me show you again. I'm coming. Let me show you again. Absolute value of 3. This will give me 3. Because here 3 is greater than 0, it will return that 3 back for me. But if I have absolute value of minus 3, what will be my answer? My answer will still give me 3. What happens? How is it becoming 3? Remember that this absolute value has automatically added a minus for you. And you can see here, x is less than 0. Is now returning minus x back for me. And that is why I'm having minus x here. That is, it's helping you to add minus again so that what you can have can turn out to be positive. And that is the absolute value function. Okay, good. So let me define. So whenever you see it, so you define it that way. The absolute value of x, this will give me what? X if you have x to be greater than 0, and to give you negative x if x is less than 0. Now, if I now want to define this function f of x, Remember the function f of x we are given is absolute value of x. We will now divide it by x, just like I'm having here. So what would that give me? If I divide this one by x, based on this I'm having here, I'll be having 1. And if I divide this one by x, I'll be having minus 1. So I'll still put my condition greater than 0, less than 0. So this is what I have. Now to find the limit, as x tends towards, remember, I'm looking at the limit as x tends to 0. So for me to get this answer, I'm going to look at it from the left and from the right if they are equal. So from the left, I have this of f of x. And remember, if I'm looking at the limit as x tends to 0 from the left, which one will I be picking? Remember, I'm picking x less than 0. Which one less than 0? This is it. And that's the limit. Sorry. This is x less than 0, so I'll be having minus 1. And what's the limit? Remember, there is no x here. It will still return that minus 1 back for you. And I'm looking at the limit as x tends to 0 from the right of f of x. Remember, 0 from the right means x greater than 0. And which of these functions have x greater than 0? 1. And what's the limit? There's no x there, just return 1 for you. Now, check it out. If you observe, the left hand limit, it is not equal to the right hand limit. So therefore, the limit as x tends to 0 of absolute value of x over x does not exist. Why that does not exist? Because the left hand limit and the right hand limit are actually not equal. And that is it. Okay, let me solve a question similar to this. If I'm having the limit as as you have, let me create one. Okay, as x tends to 2 of absolute value of x minus 2 over x minus 2. All right, let's define this. So I'll define this and say absolute value of x minus 2 will give me, this one will give me positive x minus 2 if x minus 2 is greater than or equal to 0. And this will give you negative x minus 2 if x minus 2 is less than 0. That is it. And if I want to rewrite it, I'll have this x minus 2. Here I have minus x minus 2. Here is if s is greater than or equal to 2. If I solve the inequality, and here x is less than 2. So this is what I have. So I can redefine this function as this. As what? This. I can redefine this function as what? Remember, this absolute value of x minus 2, this is it here. Now, I'm now dividing it by x minus 2. So if I divide this one by x minus 2, I'll have 1. If I divide this one by x minus 2, I'll have negative 1. So if x is greater than 2, or if x is less than 2. Now, this is what I have. So the limit as x tends to 2 from the left of f of x is equals to what? The limit as x tends to 2 from the left. From the left, what is my function? Minus 1. We are looking at the one less than 1. Okay? So my answer is minus 1. And the limit as x tends to 2 from the right of f of x, give me the limit as x tends to 2 from the right. What is my f of x from the right? That's 1. And my answer is 1. So you can say left hand limit, it is not equal to the right hand limit. So that's how to solve question of this kind. So just really need to take note of the pattern to solve this question. It is not hard. Next question. Okay. I have f of x to be defined as this. A plus bx if s is less than 1. 4 if s equal to 1. B minus ax if s is greater than 1. So, you were told that if the limit as x tends to 1 of f of x is equal to f of 1, you have to find the possible values of a and b. You can pause this video to try this question, and when you are done, let's move on powerfully. So this is the last question. All right, so let's go. Solution. Okay. Remember, we want to find the limits. Firstly, the limit of this one, left-hand limit must be equal to right-hand limit. Firstly, what is the left-hand limit? Limit as x tends to 1 from the left of f of x will be equal to the limit as x tends to 1 from the left. From the left, x less than 1, I'll be picking a plus bx. And if I'm substituting my 1 here for x, I'll be having a plus b. It means that the limit as x tends to 1 from the left of this function f of x gave me a plus b. Similarly, find the limit as x tends to 1 from the right of this same function f of x. So you'll be having the limit as x tends to 1 from the right of this function f of x. From the right, x greater than what? 1. And that is what? B minus ax. And that will give me what? B minus a. Now, we have this already. Good. Now, since we have this, firstly, we were told that before we even go to this one that we have here, take note of something. For us to have this limit to exist, left-hand limit and right-hand limit must be the same. We know that, so I'll say a plus b equal b minus a. So here I have 2a equal 0. So I have a equal to 0. So my first value for a is 0. All right. Also, we were told that this limit here is equal to f of 1. Firstly, what is f of 1? Note, f of 1 is equal to what? That is when x equal to 1. What's the value of the function? 4. So we're told that the limit is equal to what? 4. So this is what I'm going to do. Firstly, substitute your left-hand limit, a plus b, to be equal to what? 4. So I have a plus b equal to what? Equal to 4. Right? Also, you were told that this limit is equal to f of 1. A plus b is equal to 4. Also, a minus b must also be equal to what? 4. That b minus a must also be equal to what? 4. Now, if I add both equations together, I'll be having what? This will cancel out. 2b equal to what? 8. B equal to what? 4. So, I've gotten b equal to 4. What else? If I substitute this 4 back into this equation, I will get a equal to what? 0. Is there any other value again I want to get? No. So the values are a equal to 0 and b equal to 4. You can take a look again by yourself. Okay. Yeah, that's the only thing. Okay, so that's the gist. All right, so if you are new to this channel, please comment, like, and share, because that's the only way you can support me in creating more interesting videos. Thanks for watching. Bye.